Hello, parents and teachers who may be watching. Welcome to Creating Math Ahas for Parents. I'm Dr. Sandy Atkins, Sandy, and in this video, we're going to take a look at decimal multiplication. Now, if you notice, I have fraction strips here, and we've used fraction strips in looking at fraction multiplication, fraction addition, subtraction. I've used these in the mixed number multiplication and shown them, but I want to also show them for decimal multiplication, because in my mind, decimals are fractions. You might even hear me call them decimal fractions, but they are fractions where the denominators are powers of 10, 1/10, 100th, or we have 10 to the second in the denominator, 1,000ths, or 10 to the third in the denominator. So they are fractions, but they fit into our place value system because they're powers of 10 in the denominator. So I want us to keep in mind the fraction side. And what we're going to do when I show you fraction multiplication, I'm actually going to show you one example, two different ways. One will be using the area model, like we've used for mixed number multiplication, double-digit multiplication. And then I'm also going to show you the method that many of us were taught in school. But keep in mind that our goal for your child is also to understand the why of what they're doing. It's the conceptual side, not just the procedural side, not just memorizing those rules and procedures. We know for many of your children that is hard for them. They have a hard time memorizing it. But if they can understand what's going on, it's easier to remember those rules and procedures. So our goal is still towards fluency, but it's fluency with understanding. So in this particular case, I'm going to start with the area model for multiplication. And so if we think about what we've done in the past, we draw that rectangle. We think of expanded form, and I'll leave links below to the area model for whole number multiplication and for mixed number multiplication, so you can go back and look at those. Also the multiplication playlist, fraction playlist, and you can see other videos linked to that. But what we're going to do is think of 2 3/10 as 2 3/10, and we're going to cut right here. And what we're doing is we're thinking of a rectangle with the dimensions of 2 3/10. See, if you look at this, this is 2 3/10. And if you look at this length, we're going to think of that as 3 4/10. And think of it as when you tile a room, right? I can put a design in the center of the room, find the square footage for that particular design, and then the square footage for the outer design. If I add them together, I should get the total area of the room. Or likewise, if I know the total area of the room, I could find the area of the design and subtract it from the total area and know the square footage of the other tile that I need. So we use the fact that area is additive, that I could cut something up into these pieces. The other thing is, once this is cut into these pieces, so I'm going to think of this as 3 put together with 4/10 and cut here, it makes these problems a little more manageable in terms of the multiplication involved. So for some of your children, these will be easier multiplication problems. Now notice this rectangle is a 2 by 3. This is 2 by 4/10 or double 4/10. This is 3/10 by 3. Or triple 3/10. And this is 3/10 by 4/10. Now, if you notice, I'm not saying 0.3 or 0.4. In my mind, I'm going to draw another rectangle here. See, I picture this when I'm doing decimal multiplication, because it's easier for me to keep track of the decimal point. It's easier for me to keep track of the multiplication when I do this. And I'm sorry for the difference in size, but I hope that sketch makes sense to you. 2 by 3, this is 6, right? The area of that's 6. If I double 8 4/10, I'm going to get 8/10. If I triple 3/10, I'm going to get 9/10. And again, for more information about the language I'm using, please check out the fraction video on multiplying fractions less than 1, and that will explain some of that. And then 3/10 by 4/10 gives us 12 hundredths. Okay. Now, I can add those together. Here, I could have just rewritten them in their decimal form. See, this is their equivalent form for decimal numbers. If I combine them all, what did I do? And remember, this is a distributive property representation. So we're using an algebraic approach to decimal multiplication, not just an arithmetic. That algebraic approach is helpful because they're going to need it in middle school and high school. So we're building that foundation now, where the arithmetic works well at the elementary level, but it doesn't directly link, unless we make sure we build it in certain ways, to the algebra they're going to be doing later. So it's purposeful using these algebraic approaches and using models for the distributive property. Now, if you think about it, we thought of 2 and 3/10 as 2 put together with 3/10. And we thought of 3 and 4/10 as 3 put together with 4/10. And then, right, we had the 2 by 3. These put together with the 2 by 4/10, put together with the 3/10 by 3, put together with the 3/10 by 4/10. And you know, the order in which I did these in, I could have done this first, right? Because addition is commutative, I could change the order. It would come out to be the same. And then notice my values. I've got 6, 8/10, 9/10, 12 hundredths. Now remember, I can use the associative property. I've shown that before with the decimal addition, thinking of this as 7/10 and giving 1/10 over here. So I've got 6 plus 1 and 7/10 plus the 12 hundredths. So if I add it all together, I've got 7 and 82 hundredths. Okay. Distributive property, I can do a parallel between what we did with mixed number multiplication to what I'm doing with decimal multiplication. It's actually just going to be easier because these are all going to be powers of 10 with my decimals. So that's the area model approach. Let's do the same problem, but I'm going to use a little bit of the approach that we use. Sorry, a fraction piece is sticking to me here. If I do 2 and 3/10 times 3 and 4/10, the way I was taught this is we would have written it vertically. And then I was told to just ignore the decimal point and do the multiplication like they aren't there. And then at the end, you count the number of places to the right of the decimal point and move the decimal point. It was about counting. There's a lot of steps to remember in a specific order. Now, there's a reason all of that works. It's not just a trick or a forgetting or just an answer getting technique. See, what we're thinking of is we can think of 2 and 3/10 as a 10th of 23. And we can think of 3 and 4/10 as a 10th of 34. So when we were doing this multiplication of 2 and 3/10 times 3 and 4/10, essentially, I'm going to replace that with these. I could think of this as 1/10, right? 1/10. And multiplication, I can switch the order. It's commutative, right? So I could think of this as 1/10 times 1/10 times 23 times 34. I could do this product first and then come back and take 1/100th of it. That's what they were telling us to do when we were doing this multiplication, is I could think of this as 23 times 34 and then come back and take 1/100th of that product. Now, to do 23 times 34, I could still use the area model. I could use partial products, and please check out that video if you want more information about partial products, okay? So distributive property, partial products. If I'm doing this and I want to use partial products, remember with partial products, the order doesn't matter. I don't have to start on the right, but I could. If I do 4/10 times 3/10, that's going to give me the 12/100ths. 4/10 times 2, or double 4/10, is 8/100ths. Triple 3/10 is 9/100ths. 3 by 2 is 6. Now you notice how by doing partial products, I haven't saved the decimal point for the end. When I've done it this way, I've actually kept the place value, and I can add it all together. And I essentially, do you see these numbers here versus these here? See, by using the distributive property, I'm doing partial products. Okay. If I were doing 23 by 34 using partial products, I could do 4 3s, 4 20s, 3 30s, 30 20s. Well, I know that because if I know 3 times 2 is 6, then I know 30 times 20 is 600. That's a partial product approach for this double-digit multiplication, right? And then what do I have to do? 1/10 by 1/10 is 1/100th. In the end, I come back and find 1/100th of 782, which is going to be 7 82/100ths. That's what they had us do before. I don't know that at the time I understood that I was going back and taking 100th. I was essentially multiplying later, right? It was a way to get an answer. So as I've said, as we're using these techniques for decimal multiplication, whether it's the area model, if it's understanding how I'm working with multiplication for that decimal number, if I eventually use partial products that help me with it, it's that we want to make sure that your child knows more than just how to get an answer. They understand the why behind it, why it works, and can defend it. I hope this video helped. If so, please give it a thumbs up. Please share with others who might find it useful. If you would, please subscribe to the channel. It will really help us out. Also, turn on that notification bell so you know when other videos become available. Thanks so much for watching.